As night slowly settles over rooftops, forests, and the glowing cities below, there is always a familiar face watching from above. The moon. No matter whether someone lives in America, Asia, or any other corner of the world, all it takes is a glance upward to find the same soft, luminous disk hanging gently against the dark sky. For tens of thousands of years, countless generations have looked upon this sight, using it to tell stories, compose poetry, mark the passage of time, and find their bearings in long, quiet nights. The moon, in that way, is more than an object in the sky. It is a quiet, enduring part of humanity's shared memory. From a purely scientific view, the moon is simply Earth's only natural satellite, a rocky sphere about 3,474 kilometers across, circling our planet at an average distance of 384,000 kilometers. It does not shine on its own. Moonlight is merely sunlight reflected off a surface coated in gray dust. Yet, in a strangely beautiful way, that reflection creates a gentle glow, bright enough to see the world around us, yet soft enough not to sting the eyes. Many people feel as if everything on Earth is being wrapped in a thin, cool, transparent veil, a kind of quiet calm that smooths the edges of the night. Behind that serene appearance, however, lies a fierce origin story. Modern models show that about 4.5 billion years ago, when Earth was still a glowing, molten world, a Mars-sized object slammed into it. The collision released an enormous amount of energy, sending pieces of Earth's outer layers flying into orbit. Under the pull of gravity, those fragments gathered, slowly cooling, eventually forming the moon's first rocky crust. Today, when scientists analyze lunar rocks brought back by astronauts, they find chemical signatures strikingly similar to Earth's crust, as if the two worlds are whispering a quiet confirmation that they were once one. Up close, the moon's surface is nothing like the smooth impression we see with our naked eyes. It is a landscape crowded with circular scars left by billions of years of meteor impacts, interwoven with dark plains of basalt called lunar maria, places where ancient lava once surged up from below and froze in place. On Earth, wind, water, volcanoes, and shifting tectonic plates constantly refresh the surface, erasing traces of old impacts. But on the moon, there is no real atmosphere, no rain or wind, so the ancient scars remain perfectly preserved. To planetary scientists, the moon is like a natural archive, a time capsule of the young solar system's chaos. Yet the moon's influence on us is not only something buried in the distant past. Each day, the gravitational pull between Earth and its companion gently tugs at our oceans, creating the tides. As the moon passes overhead, massive bodies of water bulge toward it, and on the opposite side, forming two high tides. This steady rhythm has shaped coastlines, river mouths, and entire coastal ecosystems, indirectly influencing where humans settled, built harbors, and developed trade. On a smaller scale, that same gravity even causes Earth's crust to flex ever so slightly, as if the planet is taking a deep, unhurried breath. Too subtle for our senses, yet measurable with sensitive instruments. When humanity began sending missions to the moon, another quiet truth emerged. Our companion in the sky is slowly drifting away. By firing laser pulses from Earth to the retroreflectors left on the lunar surface, researchers have measured its distance increasing by about 3.8 centimeters each year. It's a tiny amount, so small that in a human lifetime, the moon appears unchanged. But over hundreds of millions of years, this gradual retreat will mean that total solar eclipses will no longer align as perfectly as they do today, when the moon's disk fits just right over the sun. Far in the future, eclipses will still happen. But the perfect lock-in we experience now will be only a memory of a brief moment in cosmic history. Throughout the span of civilization, humanity has always looked at the moon with two parallel perspectives: the eyes of imagination and the eyes of science. On one hand, it has inspired myths, festivals, promises, and even stories of heartbreak. On the other, it has served as a natural laboratory, drawing telescopes, spacecraft, rovers, and delicate instruments to its surface. From the first satellites that skimmed past it, to the moment the first human footprint pressed into its gray dust, and onward as missions from the United States, the Soviet Union, China, India, and Japan have orbited, landed, drilled, and sampled. Each generation has brought us closer to seeing the moon as a real world, not merely a glowing lantern in the sky. The journey ahead is about weaving all these perspectives together. From its violent birth to the peaceful glow we see now, from its inner structure to the dark basalt seas on its face, from its role in stabilizing Earth's axis to the bold missions planned by spacefaring nations, each piece finds its rightful place. The science can be unraveled gently, layer by layer, like slow-moving spirals of an orbit, allowing listeners to absorb the knowledge while letting their thoughts drift softly. And in the end, if someone closes their eyes and still sees a quiet moon hanging above, and feels a small, comforting sense that they understand that old companion just a bit more, then the journey will have fulfilled its purpose, as the lingering echoes of the moon's timeless charm are still drifting gently in the mind. Images of the full moon glow, the stillness of the night sky, that quiet sense of peace the moon leaves in the human heart. Another gentle question begins to form. Where did that soft, calming moon truly come from? And why has it stayed beside Earth for billions of years? From the tender emotion of the previous chapter, the journey continues, moving deeper into the origins of this small companion in the sky, searching for the reasons behind a history that is at once violent and delicate, ancient and familiar. Layer by layer, its secrets begin to unfold, as if behind that gentle light lies an epic stretching across cosmic time, one that tells of creation, evolution, and the unbreakable bond between the moon and Earth. About 4.5 billion years ago, when the solar system was still in a chaotic state, a Mars-sized object, later named Theia, collided with the young Earth. The impact was anything but soft. It was powerful enough to melt much of both worlds in a single fierce, cosmic instant. A vast amount of molten material was flung into orbit, twisting and swirling together, and under their shared gravity, these fragments gathered, forming a new celestial body. That was the moon in its earliest form, a glowing sphere of magma, far from the smooth, quiet world we see today. Over time, that molten surface cooled, solidifying into its first rocky crust. Relentless meteor bombardments carved ancient craters into it, many of which still remain, perfectly preserved to this day. The evidence for this story does not rest only on theory. The lunar rocks brought back by the Apollo astronauts reveal the moon's origin with remarkable clarity. Their chemical makeup nearly mirrors Earth's crust, unlike any meteorite or other object in the solar system. Like two drops of water split from the same source, the moon and Earth truly share a common past. Even though this twin sibling drifted away and settled into its own orbit, it still carries traces of its home planet in each grain of gray dust. When viewed from Earth, it is easy to underestimate the moon's true size. Its diameter, 3,474 kilometers, is only a quarter that of Earth, and its mass is just 1/81st. Its gravity is much weaker, only about 1/6 of ours. If a person could leap across the lunar surface, each step would feel airy and weightless, almost like floating. But the moon's beauty is not only in its smaller scale, it is also in the deep, dark regions we call lunar seas. These patches are not water, but vast plains of basalt, remnants of ancient lava that once welled up from deep beneath the crust. Over billions of years, with no atmosphere to erode them, these plains flattened and spread, creating broad, dark fields that contrast sharply with the rest of the moon's rugged face. Another quiet wonder. Although the moon orbits Earth in a little over 27 days, it also rotates at the exact same rate. Because of this perfect synchronization, the moon always shows the same face to us. The near side, with its dark maria and familiar landmarks, has become a constant companion. Meanwhile, the far side, the face hidden from Earth, appears rougher, more heavily cratered, like a forgotten page in an ancient book. It is not more mysterious by nature. It simply endured more impacts through time, while Earth unknowingly acted as a shield for the near side. The bond between Earth and the moon is deeper than appearances suggest. Each day, their mutual gravity makes Earth's oceans rise and fall, creating the tides. This rhythm shapes coastal ecosystems, enabling countless species to thrive. And it is not only the water, Earth's crust itself stretches and flexes slightly whenever the moon passes by, a movement so subtle that only modern instruments can detect it. Though delicate, these oscillations are part of the long, quiet relationship between the two worlds. One of the most intriguing truths is that the moon is slowly drifting away from Earth. Thanks to the retroreflectors placed on its surface by Apollo missions, scientists use laser pulses to measure the distance with extraordinary precision. The results show the moon receding by about 3.8 centimeters each year. It is a tiny shift, but a steady one. As Earth spins, tidal friction transfers energy into the moon's orbit, nudging it outward bit by bit. In the far future, perhaps hundreds of millions of years from now, total solar eclipses will no longer align as perfectly as they do today. Yet on human timescales, this change is soft and gentle, like a slow breath in the cosmic night. To understand the moon's origins and characteristics is to feel a door opening into a world both familiar and strange. The bright companion humans have long called by tender names: the Moon Lady, the Night Companion, the Lantern in the Sky, actually carries a history far deeper than one might imagine. From the giant impact that forged it, to the silent basalt seas, to the invisible but enduring bond it shares with Earth, every detail adds to its nature as a celestial body both simple and complex, close and enigmatic. And once we understand where it came from, the journey of discovery expands even further. Cultural stories, spiritual meanings, ancient myths, the space race, the first footprints pressed into gray dust, the machines, robots, and modern missions soaring upward, all of them connect back to a simple, seemingly gentle question: who is the moon in Earth's story? Over time, the answer has grown into a quiet cosmic symphony, one we are still learning, still exploring, still listening to together. As the story of the moon's origins and scientific features gently comes to a close, it feels as though one door has barely finished opening before revealing another, deeper one. The layers of information about the colossal impact, the ancient oceans of magma, the tidal locking that keeps one lunar face forever turned toward Earth, all form a steady foundation for understanding that this small world is far more than a cold, lifeless object. It is a symbol, an inspiration, a place where humanity has stored its quietest thoughts. And once we understand how the moon was born, the next question rises naturally. Why have people across every age and every culture felt so much toward a celestial body nearly 400,000 kilometers away? From the scientific grounding of the previous chapter, the journey now drifts into softer territory, the realm of culture, spirituality, and myth. In ancient times, before telescopes, before spacecraft, before precise numbers to describe orbits, the moon appeared as a mysterious companion in the sky. Night after night, its shape changed, sometimes a perfect circle, sometimes a delicate crescent, and sometimes vanished entirely into darkness. That rhythm stirred ideas of cycles, of endings and beginnings, of the endless loop of life, death, and renewal in nature. Many civilizations relied on the lunar cycle to create calendars, because its steady 29.5-day pattern was one of the most reliable signals they could observe. Even in modern language, traces of that tradition remain. The English word month comes from moon. Human biological cycles have also been compared to the waxing and waning of the moon, as if the body and the cosmos move in quiet harmony. In mythology, the moon is not merely a light in the sky, but a character, endowed with names, personalities, and powers. The ancient Greeks had Selene, the personification of the moon, gliding across the night in her silver chariot. Through her, we see how early people breathed imagination into something they could not reach. Artemis, the goddess of the hunt, and also the goddess of the moon, represented strength and freedom. NASA's choice of Artemis as the name for its return to the moon program reconnects ancient story with modern science, showing how past and future often walk together. In East Asia, China tells the legend of Chang'e, who drank the elixir of immortality and flew to the moon, living there with the Jade rabbit. The story is so beloved that thousands of years later, the nation's lunar probes still carry names inspired by it, a bridge from myth to technology. The Maya revered Ixchel, a lunar goddess linked to fertility, rain, and transformation. Beneath moonlight, Ixchel could be a youthful maiden, a gentle mother, or an aged woman, symbolizing the three stages of a human life. And in Vietnam and many other Asian countries, the story of Chi Hang and Chu Kuoi lives on in the childhood memories of generations, woven into folk tales, lullabies, and mid-autumn traditions. The moon is woven not only into stories of gods, but into the spiritual interpretation of human experience. A full moon was once believed to stir emotions, making them stronger and harder to control. The English word lunatic, meaning someone who has lost reason, comes from Luna, the moon. In European folklore, full moons were linked with mysterious transformations, werewolves, and other supernatural events. Even though modern science finds no solid evidence that the full moon harms mental well-being, the image persists as part of our shared imagination. On the other hand, many spiritual traditions view the full moon as a time of cleansing energy, ideal for meditation, reflection, or letting go of burdens. In Buddhism, full moon days mark key moments in the Buddha's life, making them both sacred and serene. Looking at moon-related festivals across the world reveals how deeply it has seeped into human life in the most delicate ways. In East Asia, poets of old often sat beneath the moonlight to write verses that captured both loneliness and natural beauty. Mid-autumn celebrations, with lanterns, mooncakes, drums, and handcrafted masks, remain among the most beautiful lunar festivals. In Japan, the Tsukimi Festival honors the autumn moon, the time believed to show the moon at its brightest and fullest. In the West, Major holidays like Easter are tied to lunar cycles. Even in modern literature, the moon remains a symbol of longing, of something beautiful yet distant, like a thin light shimmering on the water in a quiet night. In Vietnamese folk poetry, entire moon cycles are used to describe fidelity, to compare the arc of a human life with the repeating glow of each passing lunar phase. From myth to poetry, from belief to daily life, the moon has always existed as a mirror, reflecting both what is real and what humanity longs to believe. It is at once near and far, simple and enchanting, depending on the eyes of each era. When people gaze at the moon, they are not only looking at a cold sphere of rock, but into the memory of their own kind, into stories passed down through thousands of years, into hopes and quiet sorrows cast upward into the sky. And as those stories are told and retold, the moon becomes part of humanity's collective soul. As this cultural and spiritual journey comes to a close, another realm unfolds ahead. The history of exploration, the race among nations, the spacecraft that left Earth to reach that gentle light our ancestors could only admire from afar. The next chapter will open onto the age of lunar exploration, where imagination meets science, and where ancient dreams are given their first real chance to come true. As the myths and legends begin to settle, it feels as if the thin mist surrounding the moon in our imagination is slowly lifting, revealing a horizon that is more grounded, yet no less captivating. From a sacred symbol of spirituality, from a wellspring of poetry and festivals, the moon begins to appear as a real place, reachable, touchable, a world that human-made metal ships could one day explore. This moment of transition between myth and science, between stories told in moonlight and stories written by rocket engines, marks a turning point in human history. Stepping out of the pages of gods and folk tales, the moon enters the pages of engineers, scientists, and astronauts. The moonlight remains as gentle as ever, but humanity's gaze has changed. And so begins a chapter defined by competition, effort, and the restless desire to reach farther than ever before. In the middle of the 20th century, while the world was still divided by political tension, the two superpowers, the United States and the Soviet Union, entered a new kind of race. It was not fought on battlefields, but in the sky. The space race began as a symbol of scientific and technological supremacy, but quickly grew into something deeper. A quest to push beyond the limits of what humanity believed possible. In 1957, the Soviet Union stunned the world by successfully launching Sputnik, the first artificial satellite in history. Its steady radio beeps, coming from a tiny object orbiting Earth, announced unmistakably that humanity had entered a new era. Soon after, the United States answered with the Mercury and Gemini programs, laying the groundwork for an even bolder ambition: to send humans to the moon. In 1961, President John F. Kennedy made a declaration that would alter the trajectory of global science. The United States would send a human to the moon and bring them safely home before the end of the decade. Amid the tensions of the Cold War, that promise lit a fire in the imaginations of millions. For the first time, the idea of walking on the moon was no longer just a dream in literature or myth. It became a concrete political and scientific goal. Before anyone could risk traveling into that cold, silent space, nations had to send uncrewed missions. The Soviet Union led the way with the Luna series. In 1959, Luna 1 flew past the moon, opening the door to early knowledge. Soon after, Luna 2 became the first human-made object to reach the lunar surface, albeit in a hard impact. Even these sparse early data proved that reaching the moon was possible. And that same year, Luna 3 returned the very first images of the moon's far side. a region no human had ever seen. The photos were blurry, noisy, imperfect, yet they revealed a landscape crowded with craters, utterly different from the familiar near side. Meanwhile, the United States was far from idle. Despite early failures in the Pioneer program, NASA kept pushing forward. In 1964, Ranger 7 sent back the first close-up images of the lunar surface before intentionally crashing. Then came the Surveyor landers between 1966 and 1968, achieving the first American soft landings on the moon. These spacecraft did more than take pictures. They tested soil strength, analyzed chemical composition, and proved the surface was solid enough to hold human footsteps. Their success became an invaluable stepping stone, like the deep breaths one takes before attempting a long leap. Amid that frantic pace, the United States launched the ambitious Apollo program, designed to send humans beyond Earth's orbit. A giant rocket was engineered, the Saturn V, standing over 100 meters tall, capable of lifting tens of tons off the planet. The chosen mission profile was Lunar Orbit Rendezvous. The command module would remain in lunar orbit while the lander detached to descend. It was a daring strategy, requiring absolute precision at every step. Hundreds of thousands of people contributed. Every bolt, every calculation, every test carried the shared hope of a nation. And although the technology of the time seems modest by modern standards, the teams behind Apollo created something extraordinary. But the road to triumph was not gentle. In 1967, tragedy struck when Apollo 1 caught fire during a ground test, taking the lives of 3 astronauts. The shock forced the nation to confront risks that had been overlooked. Yet instead of retreating, NASA learned, improved, and redesigned, strengthening safety protocols from the ground up. 1 year later, in 1968, Apollo 8 became the first crewed mission to orbit the moon. For the first time, humans traveled far enough to watch Earth rise over the lunar horizon. The photograph of the blue planet floating in darkness stirred millions, reminding them of the fragility of their only home. At this point, the pulse of the space race was at its most intense. Both nations understood that whoever first set foot on the moon would write their name into human history. Determination, anticipation, trial after trial, uncrewed flights, early images. Each step felt like a quickening heartbeat, leading toward the monumental moment of Apollo 11. But that moment has not arrived yet in this part of the story. The narrative pauses at the threshold of one of humanity's greatest achievements, just as the world holds its breath, waiting for the first footprints on another world. And so, from shimmering moonlit legends, the journey begins to merge dream with reality. When humanity truly sets out to conquer the moon, not with prayers or ancient tales, but with rockets, engines, and courage. What comes next will open a new chapter in history, one where moonlight is no longer only observed from afar, but touched for the very first time by human feet. As the story of the space race between the United States and the Soviet Union slowly comes to a close, it feels as though the entire sky is waiting for an inevitable moment. The numbers, the test launches, the grainy far-side images sent back by Luna 3, the gentle landings of the Surveyor spacecraft on gray lunar soil. All of it seems like the earliest strokes of a much larger painting. You can sense that behind these uncrewed attempts, behind every calculation and every burst of rocket flame, there was always an unspoken but ever-present goal: the first human footprints on another world. Throughout the 1960s, the world seemed stretched thin across each step forward. Each test flight, each political declaration, each engineer's equation. On one hand, it was competition. On the other, it was the deep human desire to go beyond one's limits. And when everything was finally ready, when technology had advanced far enough, when human resolve had matured, the story reached a point that history could not turn away from. From the foundations of that fierce race, another door opened, leading to the moment humanity had awaited since the first time we looked up at the night sky, the moment of Apollo 11. On July 20th, 1969, astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins entered lunar orbit aboard Apollo 11. Under the watchful eyes of millions on Earth, they began the hours that would define a century. Armstrong and Aldrin separated from the command module in the lunar lander Eagle, preparing to descend onto a region mapped as the Sea of Tranquility. Tension traveled through every radio transmission like a drawn violin string. And when the words, "The Eagle has landed," echoed back to Earth, a gentle wave of emotion swept across the entire planet. No one could see the individual grains of dust beneath them, but everyone understood the meaning of the moment. Not long after landing, Neil Armstrong stepped down the ladder. His words, "That's one small step for a man, one giant leap for mankind," became immortal. The sentence was not merely a declaration. It was the distilled essence of decades of research, sacrifice, testing, and hope poured into the universe. Buzz Aldrin followed, and together they spent over 2 hours walking, taking photographs, and collecting more than 20 kilograms of lunar material. The black and white images beamed to Earth lacked the clarity of modern high-definition cameras, yet they carried the full weight of a generation stepping beyond its boundaries. From that moment on, the moon was no longer a distant symbol. It became a real place, marked forever by human footprints. To achieve this feat, the technology of the 1960s had to shoulder what once seemed impossible. The Saturn V rocket, towering over 100 meters tall, was one of the most powerful machines ever built. In the first 12 minutes of flight, it had to complete the most dangerous part of the journey, reaching orbit. Each massive stage separated exactly as planned, with accuracy measured in fractions of seconds. Inside the command module and lunar module were computers no more powerful than a modern pocket calculator, yet programmed, tested, and refined to be as reliable as possible. The bulky astronaut suits were in truth delicate life support systems, maintaining pressure, temperature, and oxygen in the vacuum of space. The tiny lunar lander, Eagle, was stripped down to the essentials, just strong enough to land with only a narrow reserve of fuel. And the radio communications connecting two worlds nearly 400,000 kilometers apart carried every word, every breath, back to millions of listeners on Earth. After Apollo 11, the journey did not end. The United States sent 5 more crewed missions to the moon from 1969 to 1972. Each expanded our understanding of its surface and geology. Apollo 12 landed near a surveyor probe to study how years of lunar weathering had affected it. Apollo 13, crippled by an oxygen tank explosion, became a profound lesson in ingenuity and perseverance, and ended with the crew's safe return. Apollo 14 carried Alan Shepard, America's first astronaut, who offered a lighthearted moment by hitting a golf ball in low gravity. Apollo 15 and Apollo 16 brought lunar rovers, allowing astronauts to travel farther and collect more samples. Finally, Apollo 17 closed the Apollo era with Harrison Schmitt, the first geologist to walk on the moon, who collected samples that strengthened the giant impact hypothesis of the moon's formation. In total, 12 people walked on the lunar surface. They brought back 382 kilograms of rock and soil, samples still studied today to piece together the early geological history of Earth's only natural satellite. These rocks reveal that the moon was once completely molten, that it experienced intense volcanic periods, and that it holds evidence from the solar system's earliest days. Though Apollo ended in 1972, its legacy has never faded. Astronauts who stood on the moon often describe the sight of Earth, a small, fragile sphere hanging against a black, endless sky. That image changed the way many people viewed their home planet. A small plaque reading, "We came in peace for all mankind," still rests on the moon's surface, beside footprints preserved in dust, untouched for decades. Apollo was not merely a triumph of American science. It was a milestone for all humanity, proof that we can leave our home, touch another world, and return carrying stories that are both scientific and deeply poetic. As the glow of Apollo gently settles, the story begins shifting toward a new era. Ambitions continue to simmer, technology keeps advancing, and the desire to return to the moon, this time to stay longer, to stay sustainably, awakens once more. But before those future chapters unfold, the Apollo journey remains at the heart of humanity's imagination, a reminder that sometimes a single small step can reshape the course of our entire species. As the Apollo flights came to an end, their echoes lingered, like a melody the world could not forget. 12 people had left the first human footprints on the moon, carrying stories that humanity still recalls today. From the tense landing of Apollo 11 to the quiet rovers rolling across silver plains of dust. But behind those brilliant moments, history was already shifting into a different rhythm. Not an ending, not a fading away, but a long, gentle pause, like the stillness between two chapters of an epic. The heart of lunar exploration was still beating. It had simply slowed, preparing itself for a different kind of beginning. And from the emotional swell of the Apollo era, the story naturally drifts into a new century, one where modern technologies and long-term visions begin weaving the next chapter of the moon's dream. In 1972, when Apollo 17 completed its mission, the United States brought the Apollo program to a close. Not because the dream had been fulfilled, but because budgets, politics, and shifting priorities pushed NASA toward other goals, especially the Space Shuttle program. For decades afterward, no new footprints were pressed into the lunar soil. But this quiet spell was not abandonment. NASA continued to send small, steady robotic spacecraft to circle the moon, measuring, mapping, photographing, and answering the questions Apollo had left open. In 1994, Clementine marked the beginning of a new wave of robotic missions, providing surface maps with unprecedented resolution. In 1998, Lunar Prospector mapped minerals and detected hints of hydrogen at the poles, suggesting the presence of ice. Then, in 2009, L-CROSS conducted a bold experiment. It sent a spent rocket stage crashing into a dark crater at the lunar South Pole, kicking up a plume of dust for its companion spacecraft to analyze. The results confirmed the presence of water ice hidden in the perpetual shadows. That same year, the Lunar Reconnaissance Orbiter, LRO, began circling the moon, and to this day continues to beam back images sharp enough to reveal the untouched footprints of the Apollo astronauts. Thanks to these missions, we now know the moon is not the bone-dry world we once imagined. Ice in the lunar South Pole became the key that opened the idea of living, working, and even producing fuel on the moon itself. As these data accumulated over the years, the long silent dream of returning to the moon began to awaken, this time with greater ambition and a longer horizon. And so, the Artemis program was born. NASA chose the name Artemis not only because Artemis is the Greek goddess of the moon, the twin sister of Apollo, but also as a symbolic bridge connecting the old chapters to the new. Artemis is not simply a return, it is a wiser return, a more enduring return, one that invites the participation of many nations. Artemis I, launched in 2022, was the first test, an uncrewed flight of the Orion spacecraft around the Moon, lifted by the SLS rocket, the most powerful rocket in the world today. The mission exceeded expectations, confirming that NASA's new infrastructure was ready. Artemis II, planned as a crewed lunar flyby, will echo the historic journey of Apollo 8, but with the advantages of modern technology. And Artemis III, the mission the entire world watches with anticipation, aims to land near the Moon's south pole around 2025-2026. If successful, it will mark the first human landing in over half a century, and the first time in history that a woman sets foot on another world. To prepare for these new footsteps, an entire technological ecosystem is being built. The SLS rocket, nearly 100 meters tall, provides immense thrust, enough to push Orion and its modules toward lunar orbit in a single launch. Orion itself is equipped with advanced life support, improved radiation protection, a larger cabin, and the capacity to carry 4 astronauts millions of kilometers from home. The HLS lander, a specialized version of SpaceX's Starship, will carry astronauts from orbit down to the surface and back to their staging point. It offers generous interior space, the ability to transport heavy equipment, and crucially, reusability, making sustained exploration more realistic than ever. Another essential component is the Lunar Gateway, a small space station orbiting the Moon, serving as a rest stop and preparation site before descending to the surface. Built through international collaboration, with modules provided by Europe and Japan, Gateway transforms Artemis into a profoundly global endeavor, reflecting the idea that exploring the Moon is a shared human effort. Artemis astronauts will also wear the next-generation XEMU spacesuits, far more flexible than the Apollo suits. They are designed for long hours of work in the extreme cold of the lunar South Pole, where temperatures plunge to unknown lows and deep, shadowed craters shelter ancient ice. But Artemis is not limited to a few missions. Its long-term goal is to build Artemis Base Camp, a true lunar outpost. It will include modular habitats, power systems, rovers, and tools that allow astronauts to stay for extended periods. The South Pole was chosen because of its abundant ice, which can be split into hydrogen and oxygen, vital for fuel, drinking water, and life support. Using lunar resources will dramatically reduce the cost of transporting supplies from Earth, making a sustained presence possible. Artemis is also supported by the Artemis Accords, a network of agreements between many nations to explore and use the Moon peacefully and responsibly. This transforms lunar exploration from a race into a collaboration, a union of many dreams and many minds. Seen as a whole, Artemis feels like a sunrise, a new dawn in which humanity doesn't just visit the Moon briefly, but stays, works, studies, and prepares for journeys farther still. From the footprints left by Apollo to the shimmering maps of hidden ice, from the towering silhouette of the SLS rocket to the international cooperation behind Gateway, everything seems connected in a long, continuous chain leading toward the future. And thinking about that future, it feels as though we are standing at the threshold between a glorious past and a hopeful tomorrow. A tomorrow where the Moon is not only a place where footsteps once echoed, but a place where new ones are waiting to be written into the story of humankind. After following the long arc of America's lunar journey, from the golden pages of Apollo to the modern vision of Artemis, The story of the moon shifts into a new rhythm. Space has never belonged to just one nation. Every discovery, no matter where it comes from, adds to humanity's shared map of our quiet companion in the night sky. And while the United States prepared for its return, on the opposite side of the world, another rising power was quietly nurturing its own lunar dream. Not through bold declarations, but through steady, patient, almost whisper-soft steps. From the forward momentum of Artemis, the narrative drifts gently into another chapter, one shaped by spacecraft named Chang'e, opening a new era of lunar exploration. In 2007, beneath a silent night sky, China sent its first message on the path to the moon with the launch of Chang'e 1. It was not a mission meant for spectacle, but a foundational step, a deliberate choice to move slowly, surely. When Chang'e 1 entered lunar orbit at about 200 kilometers above the surface, it began a vital task: mapping the moon with laser altimetry and multispectral cameras, producing a 3D model more detailed than anything China had ever possessed. In the vast darkness of space, its instruments measured the distribution of elements like magnesium, titanium, and aluminum, painting a chemical portrait of the lunar soil. At the same time, ground-penetrating radar scanned deeper layers of regolith, gathering information that would one day guide safe landings. For 16 months, Chang'e 1 circled the moon with steady patience, collecting layer after layer of data like someone gathering grains of dust for a much larger picture. When its mission ended, it was intentionally guided down to impact the moon, marking China's first physical trace on the lunar surface. Not a dramatic landing, but a quiet, purposeful period at the end of its first chapter. 3 years later, Chang'e 2 was launched, continuing the work its predecessor had begun. This time, the spacecraft entered a lower orbit, less than 100 kilometers above the surface, allowing it to capture high-resolution images of both poles. These images were not only visually striking, but also scientifically essential for choosing landing sites for future missions. Over Sinus Iridum, the Bay of Rainbows, a region of smooth plains surrounded by ancient craters, Chang'e 2 dipped its orbit to just 15 kilometers. From that height, it could identify subtle ridges, small landslides, and terrain textures that were invisible from farther distances. By late 2012, after completing all mission goals, Chang'e 2 did not simply retire. Instead, it was guided outward into interplanetary space. It flew past the asteroid Tutatis at a distance of only a few kilometers, capturing close-up images of a small, tumbling world drifting through darkness. This achievement marked China's first demonstration of deep space navigation and long-range operations, quiet but meaningful indication of its growing capability. These early steps made no grand headlines, yet each piece of data quietly laid the foundation for what would come next. The early Chang'e missions were like careful entries in a long scientific journal, each recorded detail preparing for breakthroughs that lay ahead. For China, lunar exploration was never a symbolic race. It was a strategic scientific roadmap. The priority was to understand the lunar surface, terrain, and orbital environment thoroughly before attempting landings or sample return missions. This cautious approach minimized risk and increased the chances of success in later stages. Looking back at Chang'e 1 and 2, it becomes clear how different China's early lunar efforts were from those of the United States and the Soviet Union in the 1960s. Decades earlier, each superpower rushed to demonstrate something monumental, fast, bold, and sometimes willing to accept failure in exchange for speed. China chose another path: gather data, refine the technology, then step gently toward the surface. That patience and methodical strategy paved the way for later missions. Chang'e 3, 4, 5, and 6 to achieve results the world could not ignore. From Artemis to Chang'e, humanity's lunar journey now appears like an ever-expanding map, stretching wider with each passing decade. Every nation, with its unique pace and philosophy, contributes a thread to the shared tapestry of exploration. And when we look up at the night sky, the moon still hangs there, quietly watching each small spacecraft circle it, witnessing every persistent human effort to understand our origins and our future. Chang'e 1 and 2 are only the first steps, but they open the door to a new chapter in humanity's story of reaching for the moon. From here, the narrative will lead us to moments when the first wheels of the Jade rabbit rover pressed into fine, ancient dust, when the far side of the moon was explored for the first time, and when some of the youngest lunar rocks ever collected were carried home from a place no human has ever touched. But before those chapters unfold, the Chang'e story begins with these quiet orbits around the moon, light, gentle, but powerful, laying the groundwork for a new era of lunar exploration. As the orbits of Chang'e 1 and Chang'e 2 came to an end, they left behind a treasure of rich data, like the first careful strokes on a full portrait of the moon. The 3D maps, mineral measurements, and crisp images of the lunar poles became the solid foundation that allowed China to step beyond the safety of orbit. From two quiet spacecraft circling the moon, the story began to shift. Much like an artist who completes the outline and then lifts a second brush to paint the first strokes of color, China's lunar journey moved into the phase of truly touching the surface. And from that turning point, the narrative glides gently toward the moment when the Jade rabbit pressed its wheels into the silver dust. Dust untouched by any modern human presence for billions of years. In December 2013, after many years of quiet preparation, China launched Chang'e 3, sending it toward Mare Imbrium, one of the moon's great basalt plains. For 37 years, no spacecraft from any nation had successfully performed a soft landing on the lunar surface. The last success had been the Soviet Union's Luna 24 in 1976. Since then, the moon had remained still, observed from afar, but untouched. So when Chang'e 3 approached the surface, slowing its descent with precise maneuvers, the eyes of scientists around the world were fixed on the moment. And then, in the silence of the cosmic night, Chang'e 3 touched down in Mare Imbrium, marking the first successful soft landing in decades. From the lander, the U2 rover, the Jade rabbit, began the next chapter of the journey. Its arrival was not a dramatic flourish, but the natural continuation of all the data and effort built by Chang'e 1 and 2. U2 was small and modest in appearance, yet carried remarkable technological capability. A dual-frequency ground-penetrating radar, an infrared spectrometer, and multiple cameras. When its wheels rolled across the fine dust of Mare Imbrium, the movement was not merely mechanical. It was the transformation of knowledge, from the cold numbers of orbit into the direct experience of the surface. Over nearly 3 months under the moon's cold sunlight, U2 conducted a series of measurements that revealed the hidden layers beneath the regolith. Its radar probed several meters deep, recording the strata of ancient lava flows that now form the basalt plains. Although a malfunction shortened its mission, U2 still sent back more than 200 panoramic images and a wealth of soil and rock data. These images were not only aesthetically striking, they also held scientific value, showing soil porosity, particle sizes, and the textured landscape of Mare Imbrium at a detail never before seen. 5 years later, when U2's journey had become a treasured memory, China began a new chapter with the Chang'e 4 mission. To land on the moon's far side, a region Earth can never see, and where radio signals cannot be sent directly, China launched the Kueqiao relay satellite to the Earth-Moon L2 point. Kueqiao served as an invisible bridge, catching signals from Chang'e 4 on the far side and sending them back to Earth. When Chang'e 4 touched down inside the von Karman crater in early 2019, it became the first spacecraft in human history to land on the far side of the Moon. No nation had ever done so. The far side, with its rougher terrain, denser crater fields, and thicker crust, has long been regarded as one of the Moon's most mysterious regions. Once the lander was secure, the U-22 rover began to move across a surface no human eye had ever seen directly. Its first days were a steady rhythm of discovery, panoramic imaging, mineral analysis with infrared spectrometry, and ground-penetrating radar scans mapping the structure beneath the crater floor. Some measurements suggested that the soil on the far side was thicker and more complex than on the near side, perhaps connected to the Moon's early formation and the billions of years of impacts shaping its geology. U-22's observations opened questions about ancient lava flows, compositional differences between the two hemispheres of the Moon, and the role of massive impacts in shaping its history. Each image and each measurement filled in pieces of humanity's incomplete understanding. In the absolute stillness of the far side, where there is no wind, no sound, and no direct gaze from Earth, the tracks of U-22 pressed quietly into the gray dust. Those small wheel marks symbolized far more than the success of a single mission. They were the embodiment of knowledge expanding across generations of technology. From the orbits of Chang'e 1 and 2 to the surface landings of Chang'e 3 and 4, from early measurements to deeper investigations, this journey unfolds like a book written page by page. Looking back at the entire process, from silent orbits to the first wheel tracks, it becomes clear that China entered lunar exploration in its own distinctive way. Patient, scientific, and unhurried. And that steady approach carried China to become the third nation in history to achieve a soft landing on the Moon, and the first to explore its far side. The Jade rabbit's tracks, small as they are, carry meaning that stretches across time. They record a chapter of humanity's upward journey, a reminder that every great step begins with orbits that once seemed simple. And in the vast, quiet space above, those tracks remain, like a message written gently on a distant, familiar world. As U-22 continued to leave its steady tracks across the quiet far side of the Moon, China's lunar journey took on a new layer of meaning. The faint grooves pressed into the silver dust seemed to whisper that exploration is not only about looking and measuring. Every meter that the Jade rabbit rolled forward raised a deeper question. Could humanity bring an actual piece of the Moon back to Earth? Something we could touch, study, and examine with instruments far too delicate for any robot to carry? From that thought, the story gently shifts from the roaming footsteps of robots to the longing to hold a fragment of lunar history. And at that crossroads, China entered a new phase, the era of sampling and return. After the successes of Chang'e 3 and Chang'e 4, the dream no longer felt distant. In November 2020, under the quiet night sky, China launched the Chang'e 5 mission. It was no longer just a lander or a rover. Chang'e 5 carried a far more ambitious goal than any previous Chinese mission: to collect lunar soil and return it to Earth. This was a task only the United States and the Soviet Union had achieved, more than 40 years earlier. From 1976 to 2020, humanity did not receive a single new gram of lunar material. So the launch of Chang'e 5 felt like a clear chime echoing through the scientific world. After its long journey through the cold vacuum of space, Chang'e 5 touched down on a carefully chosen basaltic plain. This region is believed to belong to one of the youngest volcanic flows still visible on the Moon, much younger than the sites sampled by Apollo or Luna. That meant that any grain of dust collected here could reveal a new chapter of the Moon's geological evolution. Once settled on the surface, Chang'e 5 deployed its systems. A robotic arm, built to withstand vacuum, extreme temperatures, and abrasive lunar dust, began its work, drilling deep into the regolith to gather samples from multiple layers, while also scooping loose fragments from the surface. Every movement of that arm was the product of thousands of tests on Earth, all to ensure that each operation would be flawlessly precise across 250,000 miles of distance. After many hours of continuous work, roughly 2 kilograms of lunar soil and rock were sealed inside an airtight container. This step was crucial. Contamination would greatly reduce their scientific value. The sealing system of Chang'e 5 functioned like a miniature safe, protecting the samples from radiation, impacts, and temperature swings throughout the journey home. But the achievement did not end with collecting the samples. The mission's hardest challenge lay in the phase that only a few nations had ever mastered: launching the samples into lunar orbit and returning them to Earth. Chang'e 5's small ascent module fired its engine, lifted off the surface, and rendezvoused with the orbital module in an automated docking maneuver. It was China's first lunar orbit docking, a technological milestone showing that the nation was approaching some of the most demanding standards in space exploration. On December 17, 2020, the return capsule entered Earth's atmosphere and landed in Inner Mongolia. Inside that small shell were the first 2 kilograms of lunar material humanity had obtained since 1976. Analyses revealed that the Chang'e 5 samples were billions of years younger than the Apollo and Luna samples, opening a fresh window into the Moon's volcanic and thermal history. From those tiny grains, scientists are redrawing the Moon's evolutionary timeline, raising new questions about the internal activity that once pulsed beneath a crust now grown cold. Chang'e 5 made 2020 a landmark year, but China did not stop there. In May 2024, the country launched Chang'e 6, an even bolder mission, to collect samples from the far side of the Moon, a region from which no material had ever been returned. This mission was even more challenging than Chang'e 5 because the far side cannot communicate directly with Earth. Once again, a relay satellite became the bridge, ensuring stable communication in a region filled with radio silence. Chang'e 6 landed gently on the far side and deployed a sampling system similar to that of Chang'e 5, but the geological conditions were entirely different. The far side has a thicker crust, denser terrain, and a longer history of meteorite bombardment. Sampling here was not only a mechanical challenge, it was a precious scientific opportunity to understand why the Moon's 2 faces are so dramatically different. On June 25, 2024, the Chang'e 6 return capsule arrived back on Earth, carrying roughly 2 kilograms of material, this time from a place no human or machine had ever touched before. These samples may reveal older chapters of lunar history, potentially containing traces of ancient impacts or signatures from the Moon's earliest crust. Both sample return missions, Chang'e 5 and 6, depended on the coordination of many advanced technologies: the heavy lift Long March 5 rocket, autonomous navigation systems, drilling robots, ascent modules, orbital docking techniques, and re-entry capsules designed to protect fragile samples. Each component functioned like a link in a seamless chain, pulling China's lunar ambition steadily forward. With the data and samples now in hand, China is laying the groundwork for a future robotic research station near the Moon's south pole. And beyond that, human Chinese footsteps on the Moon may arrive within the coming decade. In this gentle turning of the story, from the first tracks of the Jade Rabbit to the grains of dust brought home, you can feel that a new chapter of cosmic exploration is unfolding. A chapter in which each nation, each mission, each sample contributes to unveiling the mysteries hidden in the moon's quiet, ancient dust. As the precious lunar samples from Chang'e 5 and Chang'e 6 return to Earth, humanity's moon story entered a curious harmony between tradition and modernity. From the grains of young volcanic dust to fragments gathered from the mysterious far side, the world understood that the exploration of the moon no longer belonged to a single nation. The milestones China achieved in the 2020s planted a gentle truth in the global consciousness. Every country, no matter its starting point, can step onto the cosmic stage in its own way. And from the echoes of these sample return missions, the story naturally drifts toward another land, one where a nation has quietly begun writing the first chapter of its own lunar journey. From the skies of East Asia, the gaze turns southward to the Indian subcontinent, where the dream of the moon began with a single name, Chandrayaan. With Chandrayaan 1, India opened its first door to the distant universe. In October 2008, from the launch site at Sriharikota, a PSLV rocket carried a small but ambitious spacecraft into space. Chandrayaan 1 did not look like a breakthrough mission at first glance, but within it pulsed the determination of a nation rising in the realm of space science. When the spacecraft entered lunar orbit at an altitude of about 100 kilometers, India officially became the fourth country in history to place a spacecraft around the moon. From that vantage point, Chandrayaan 1 began its steady loops, tirelessly observing the silvery surface below. A stereo camera recorded ridges, impact craters, and slopes eroded over billions of years. Under shifting angles of light, it built 3D terrain models, allowing scientists to visualize depth, angles, and structural features across the landscape. X-ray and gamma-ray spectrometers listened to the energetic signals emitted by lunar minerals under sunlight, revealing surface chemistry, magnesium, silicon, aluminum, titanium, and more. Every measurement was like a musical note in a broader symphony, weaving together into a global mineral map unlike anything the world had possessed before at such detail. But the most remarkable legacy of Chandrayaan 1 came from a tiny device, the Moon Impact Probe. This small module, marked with the Indian flag, was programmed to free fall near the Moon's south pole on November 14, 2008. As it struck the surface, a brief plume of dust rose, and in that moment, the probe transmitted a crucial data stream. Its spectrometer detected hydroxyl signals, a chemical bond between hydrogen and oxygen within lunar soil and rocks. This was the first orbital evidence of water on the moon in chemically bound form. The discovery rippled instantly through the scientific community, reshaping global understanding of lunar polar regions and laying the groundwork for later missions from many nations. In the days that followed, Chandrayaan 1 continued its work without pause. It created a global mineral map, identified titanium-rich patches, measured surface temperatures, and monitored how they changed over time. Using multispectral data, scientists distinguished young basalt from ancient flows and recognized some of the moon's oldest surviving terrains. Piece by piece, India was assembling one of the most comprehensive datasets on lunar surface chemistry and geology. Although Chandrayaan 1 lost contact in August 2009, several months earlier than planned, the mission had already achieved nearly all its objectives. In truth, the amount of data it returned in less than a year far exceeded initial expectations. Those mineral maps and the discovery of water became the foundation for India's next steps. Chandrayaan-1 became a symbol of ISRO's capability, proof that India could design a major scientific mission, collaborate internationally, and deliver findings of global value. Chandrayaan-1 was not only a technological milestone, it was a spiritual one. For many Indians, seeing their national flag reach the lunar surface, even in the form of an impact probe, became a moment of deep pride. It showed that a developing nation could claim its seat among the explorers of space, contributing its own voice to the grand chorus of scientific discovery. And from the success of Chandrayaan-1, India's lunar journey did not slow. It expanded into a series of new chapters. What the first spacecraft left behind was not just scientific data, but a growing confidence. The belief that India could go further, sending landers, rovers, and perhaps one day returning samples or supporting joint missions in the promising polar regions. As the Chandrayaan-1 chapter closes, it feels like standing at a crossroads between past and future. From China's sample return triumphs to India's orbital discoveries, the tapestry of lunar exploration grows richer, like a long epic in which each nation contributes its own melody. And in this slow, gentle rhythm of storytelling, the narrative prepares to move onward, toward the moment when India takes a bolder step with its first ambitious lunar landings. When Chandrayaan-1 brought its journey to a close in late 2009, it left behind not only India's very first mineral maps of the entire lunar surface, but also a quiet shift in the way the international scientific community saw the moon. A nation without a long history of lunar exploration had, in just a single year, delivered a discovery powerful enough to ripple through laboratories in the United States, Europe, and Japan. Signs of water on the moon. From that moment forward, the story of our lunar neighbor was no longer the private realm of countries with decades of technological heritage or vast economic strength. It became a shared narrative, one where any nation, upon stepping in, might reveal something new. And in that gentle transition from the success of Chandrayaan-1, India began preparing for the next challenge, one more difficult, more daring, and demanding a level of precision few missions achieve on their first attempt. With newfound confidence and experience, ISRO launched Chandrayaan-2, a mission regarded as a bold leap for India's space technology. In July 2019, from the Sriharikota launch site, the GSLV Mk3 rocket carried its trio of components, the orbiter, the Vikram lander, and the Pragyan rover, into space. If Chandrayaan-1 had simply circled quietly from above, Chandrayaan-2 carried an entirely different ambition: to touch down, to roam, and to place its wheels upon the billions-year-old dust near the moon's southernmost terrain. It was a goal only a handful of nations had ever achieved, and India chose to take on the challenge. The journey took weeks. As the spacecraft neared the moon, its orbit gradually stabilized until the critical moment arrived. Vikram detached from the orbiter to begin its descent. September 7, 2019 became one of ISRO's most unforgettable days. As Vikram lowered its altitude, every calculation aligned. The braking engines fired in phases, and early signals suggested the descent path was even more precise than simulations. But at roughly 2 kilometers above the surface, everything fell silent. The signal vanished without warning. After hours of analysis, ISRO confirmed that Vikram had crashed, very close to its intended landing site. Pragyan never had the chance to take its first steps. Yet that moment was not a simple failure. It was a testament to India's willingness to enter the realm of difficult landings, a realm where even major powers have stumbled. The history of lunar exploration is filled with hard impacts, vanished spacecraft, and long stretches of waiting between attempts. And when Chandrayaan-2 is placed within that history, it becomes clear that India had stepped onto the same path many others once walked. But the story of Chandrayaan-2 is far larger than Vikram. In orbit, the Chandrayaan-2 mothercraft continued to perform flawlessly. Its cameras, among the highest resolution ever used for lunar exploration, began photographing the South Pole in extraordinary detail: slopes, ridges, crater structures, and the perpetual shadows that never see sunlight. Through these images, Vikram's crash site was identified. Meanwhile, the ground-penetrating radar and infrared spectrometer swept across the surface, searching for water signatures, minerals, and subtle geological changes under shifting sunlight. These datasets became a wellspring of international research. Scientists used Chandrayaan-2's observations to pinpoint likely ice-bearing locations, estimate soil depth, and compare mineral patterns across the polar region. When matched with NASA's LRO data and Japan's Kaguya readings, researchers realized that Chandrayaan-2 was filling a crucial gap in the Moon's scientific map. The South Pole, the very region the world is now aiming for in a new generation of landers. From a technical perspective, the lessons learned from Vikram became invaluable assets. ISRO analyzed the anomaly to better understand how the braking engines behaved during the final phase, how navigation systems responded to velocity deviations, and how control algorithms needed refinement. These lessons didn't simply explain what went wrong. They illuminated what would be required to succeed next time. And this is what defines the true nature of Chandrayaan-2. A mission not perfect, but complete in its contribution to science and knowledge. Because lunar landings have never been easy. Russia, the United States, China, they all faced moments of silence, setbacks, and long pauses. Every triumph was built atop earlier failures, upon vanished signals and hopes that faded before returning in the form of data and discovery. Today, when people look back at Chandrayaan-2, they do not remember it as a failed mission. They remember it as a vital chapter in India's long lunar story, a chapter in which the nation embraced risk, dared to try, dared to learn, and chose to rise again, laying the groundwork for the next chapter, the one that leads toward true footsteps near the Moon's mysterious southern frontier. And from this blend of success and challenge, the story now prepares to move forward into a new chapter where India steps with greater strength, greater precision, and greater persistence, until one day, the tracks that once remained unfinished may finally be completed under the Moon's pale light. When Chandrayaan-2 closed its chapter with hard-earned lessons and a rich treasury of orbital data, the atmosphere around India's lunar journey seemed to settle into a gentle, contemplative quiet. The sharp images of the South Pole, the ground-penetrating radar readings, the graceful infrared spectra tracing minerals and hints of buried ice, all of it felt as though it was waiting, patiently, to be carried into something larger. The loss of Vikram in 2019 did not dim the light Chandrayaan-2 had ignited. If anything, it became a necessary pause, a moment in which India could look inward at its technological framework, identify the delicate links that needed strengthening, and gather enough conviction to rise once more. From that lingering ache, the story drifted naturally into a new phase, one where determination was tested again, but this time with a maturity and calmness that felt profoundly different. And from that quiet turning point, the path led toward Chandrayaan-3, the mission that would bring India closer than ever to the Moon's southern frontier. In July 2023, when the Mark III rocket lifted off from Sriharikota, it carried not just a spacecraft, but the hopes of a nation that had once stood on the threshold of success without quite being able to touch it. Chandrayaan-3 was designed with clearer goals, a sturdier guidance system, and control mechanisms refined through every lesson learned before. Without the complexities of an orbiter, the mission focused wholly on landing, a purpose entrusted once again to a familiar duo, an upgraded Vikram lander and the Pragyan rover. The journey to the moon stretched across more than 40 days. Every orbital adjustment, each gentle burn of deceleration, and every command sent from Earth pointed toward one singular moment. The instant Vikram would need to touch down near the South Pole, where sunlight glows only briefly and darkness lasts almost half a month. It was a challenge formidable even for the world's leading space agencies. Rugged slopes, scattered rocks, violent temperature swings. Everything about the region made it a place few spacecraft had dared to approach. But it was also precisely where the world needed to look, for the lunar South Pole is believed to hold frozen water, an essential resource for the future. On August 23, 2023, the decisive moment arrived. From an altitude of roughly 30 kilometers, Vikram separated from its orbital stage and began its autonomous descent. Its engines gradually adjusted thrust, slowing the spacecraft from nearly 6,000 kilometers per hour to just a few meters per second. The navigation algorithms, strengthened by the hard lessons of Chandrayaan-2, tracked position, altitude, and terrain continuously. In the final seconds, the world waited in a stretched, breath-held silence. Then came the confirmation. Vikram had touched the lunar surface softly and precisely, right at the South Pole, a place no nation had ever reached before. In that moment, India became the fourth country to achieve a successful soft landing, and the first to set a spacecraft down in the moon's mysterious southern region. It was a historic triumph, carrying forward the pride kindled by Chandrayaan-1 and deepened by Chandrayaan-2. Moments after landing, Vikram's hatch opened, revealing the small, bright frame of the Pragyan rover. Its name, Pragyan, meaning wisdom in Sanskrit, suited its purpose perfectly. The six-wheeled rover carried delicate sensors crafted to understand the ground it was about to touch. Pragyan rolled gently down the ramp, imprinting its first tracks onto the fine lunar dust touched only faintly by the South Pole's weak grazing light. From that instant, the scientific mission began. Pragyan used its Leib's laser spectrometer to fire pulses into the soil and analyze the reflected light to determine chemical composition. The results delivered an immediate and delightful surprise: the presence of sulfur in the lunar South Pole's soil. Signals of iron, titanium, calcium, and other elements soon followed. The discovery of sulfur was especially important, hinting at the possibility of energy-rich compounds that may one day support resource extraction and in-situ material production. Meanwhile, Vikram conducted experiments the rover could not. The Chang'e thermal probe was driven about 10 centimeters into the ground to measure how temperature changed with depth. Its readings revealed that the surface warmed more quickly than expected in sunlight, offering vital insight into the insulating qualities of lunar regolith. Vikram also carried the ILSA seismometer, India's first device designed to listen to vibrations within the moon. ILSA detected gentle tremors, helping scientists understand the interior structure of the South Pole, a region never before studied through seismic instruments. For 2 weeks, one full lunar day, Vikram and Pragyan operated on sunlight, completing every scientific assignment they were given. When the bitter cold of lunar night arrived, temperatures plunged to levels fatal to electronics, and the duo drifted into deep sleep. Though they never woke again, they had fulfilled their mission with rare completeness. Chandrayaan-3 was not only a technical success, it became a defining piece of India's spacefaring dream, a dream built upon Chandrayaan-1's early steps, tested through the quiet heartbreak of Chandrayaan-2, and finally realized through the steady maturity of Chandrayaan-3. Through that progression, India's lunar exploration entered a new era, opening the door to international collaboration, polar resource research, and missions even more ambitious in the years ahead. As the story of Chandrayaan-3 comes to a close with Pragyan pressing its tracks into the fine dust of the lunar South Pole, India's moon journey feels as though it has completed a graceful arc. From the infrared measurements of Chandrayaan-1 to the heartbreaking fall of Chandrayaan-2, to the quiet resurgence of Vikram and Pragyan in 2023, listeners can sense the maturity of a nation that has persisted in stepping into places no one had touched before. The experiments on sulfur, temperature, and seismic activity near the South Pole opened a new window into understanding the frigid structure of a region touched by sunlight for only a handful of days before darkness returns. And just as that story softens, the natural flow of the journey leads us eastward, toward a country whose approach to the moon carries its own unmistakable tone, poetic, delicate, and infused with the meticulous spirit of Japanese science. Not through rovers rolling across the surface, nor through landers settling onto ancient basalt plains, Japan chose to approach the moon from above, like an artist pausing to take in the entire landscape before making the first stroke. And from this philosophy, the Kaguya mission, also known as Selene, was born, carrying with it the idea of a celestial princess quietly circling the moon and listening to its every breath. From that moment, the story drifts gently into the year 2007, a year marking a significant shift in Japan's presence on the map of lunar exploration. On September 14, 2007, from the Tanegashima launch site, an HIIA rocket carried Kaguya away from Earth. Named after the moon princess of the folktale The Tale of the Bamboo Cutter, Kaguya was both a cultural symbol and a sophisticated scientific craft, reflecting Japan's deep harmony between tradition and technology. After 2 loops around Earth, Kaguya fired its engine, left Earth orbit, and glided toward the moon. By early October, the nearly 3-ton spacecraft slipped into a polar orbit around the moon, beginning a mission that would last almost 2 years. At an altitude of about 100 kilometers, Kaguya drifted over deep shadows, ancient mountains, and vast, silent craters. It carried an array of advanced instruments: a high-definition TV camera developed by NHK, a laser altimeter to map topography, a gamma-ray spectrometer to detect radioactive elements, charged particle detectors, and a multispectral camera to capture subtle color variations across the surface. Each orbit, each measurement, each spectral curve added another layer to the growing scientific portrait of the moon that humanity was still trying to complete. But the part of Kaguya that touched the public's heart was the HD TV footage it sent home. For the first time, the Earthrise, an image previously known from Apollo, was filmed in high definition, so clear and gentle that viewers felt as though they were standing on the moon itself, watching it unfold. The soft blue sphere, fragile and glowing, slowly rose over the jagged horizon of gray lunar rock, then drifted quietly across the pitch-black sky. These scenes aired on Japanese television and spread across the world, becoming beautiful symbols of the union between science and art. Kaguya did more than observe. It released 2 small satellites, Okina and Una, into different orbits to help measure the moon's gravitational field. By combining data from all 3 spacecraft, scientists identified gravity anomalies hidden beneath the crust, mascons that had once disturbed Apollo orbits in the 1960s. These measurements produced the most detailed global gravity map of the Moon to date, guiding future missions towards safer trajectories. Kaguya's spectrometers also revealed the distribution of radioactive elements such as uranium, thorium, and potassium within the lunar crust, helping verify scientific models of the Moon's formation. Unexpected electric field readings showed that near the full Moon, interactions among sunlight, energetic particles, and the lunar surface create strong electrostatic charging, enough to affect spacecraft and astronauts, a safety concern the world had never fully accounted for. After nearly 2 years in orbit in June 2009, Kaguya completed its mission. The spacecraft was guided downward, ending its journey with a controlled impact that left a brief flash before silence took over. And like the princess in the old tale, Kaguya returned to the Moon, leaving behind a vast scientific legacy. That legacy belongs not only to researchers, but to anyone who has ever looked up at the night sky and wondered what the Moon truly looks like from angles we had never seen. After Pragyan pressed India's tracks into the South Pole, Kaguya reminded the world of another path, one shaped by patient observation, gentle curiosity, and the quiet precision that expands human knowledge in subtle but profound ways. And from that story, the Moon's journey unfolds yet another branch, leading us onward through other nations, other dreams, all reaching toward the silent world drifting around Earth. When the echoes of Kaguya finally faded, listeners could still feel the lingering shimmer of those HD images drifting through a silvery gray emptiness, where Earth's soft blue sphere once rose slowly from a jagged horizon of craters. The gravity measurements, the topographic maps, and the deep structural slices beneath the lunar surface that Kaguya returned made the Moon feel more complete, more layered, and somehow more emotional. Perhaps it was that quiet harmony, scientific precision woven with a delicate, almost fragile beauty from a distinctly Japanese point of view, that turned the mission into a gentle pause in the ongoing flow of exploration. And from that pause, the story naturally shifted toward a new chapter, one in which Japan's next steps reached closer to the lunar surface, more practical, more decisive, yet still infused with the same refined sensibility they have shown for decades. If Kaguya could be imagined as a celestial maiden floating between sky and space, gazing down at the Moon with a serene, contemplative tenderness, then Japan's later missions reflected a more concrete longing to truly place their own technological footsteps on lunar soil. To understand that desire, we need to go back for a moment to 1990, when Japan's lunar journey was still little known. That was when Hiten, a small, humble spacecraft, departed Earth. It carried no sophisticated cameras or complex scanners. Hiten was simply a technological experiment. Yet that experiment marked Japan's first touch of the Moon. The spacecraft flew past it and then fell freely to the surface, leaving behind a quiet but meaningful imprint. Hiten opened the door softly so that 3 decades later, Kaguya could step through with elegance and emotion. From Hiten's final fall to Kaguya's sweeping images, Japan had traveled a long road, and Kaguya's success awakened a new vision. If the Moon looked so breathtaking from above, then why not try touching it with their own technological feat? A subtle but persistent idea formed, slowly growing through study after study, small project after small project, each one adding another line to the blueprint of the future. And so, as the 2020s began, that wish became action. Japan did not hurry to build an enormous spacecraft. Instead, they chose to begin with something small, compact, refined, and purposeful. SLIM, the smart lander for investigating Moon. Not powerful like giant rockets, not overwhelming like heavy landers, Slim embodied a deeply Japanese philosophy. Height and weight are secondary. Precision and elegance matter more. In 2023, Slim left Earth aboard an H-2IA rocket. The space ahead was quiet, and the small craft began a fuel-saving, patient journey, adjusting its trajectory bit by bit. On December 25, 2023, Slim entered lunar orbit, carrying with it the hope of a flawless landing. Data showed the spacecraft gradually lowering its altitude, its advanced terrain recognition system preparing for a crucial task, selecting a safe landing site within just about 100 meters of the intended target. It was a level of accuracy only the most sophisticated missions had ever dared to attempt. And then, on the night of January 19, 2024, as the decisive moment drew near, streams of data revealed Slim adjusting its altitude, slowing down, rotating its body just as planned. No one could hear a sound from that distant vacuum, but every returning signal felt like the softest breath settling into stillness before touching the ground. At last, Slim passed through its most difficult seconds and set down safely on the lunar surface. The moment Japan became the fifth nation to achieve a successful soft landing seemed to etch itself into humanity's shared story. But Slim was more than a milestone. It carried two tiny micro-rovers, capable of separating on their own and moving around the landing site. These miniature robots were not only proof of Japan's technological skill, but also important tests for future communication and mobility systems. The data they sent back opened the possibility of deploying teams of small rovers for local surveys, especially in regions where humans or larger robots might struggle to reach. Japan did not stop there. They continued expanding their role in international partnerships. JAXA joined NASA's Artemis program, contributing a module for the Gateway, a future lunar orbiting station that will serve as a staging point for crewed missions. Japan also partnered with the United States and other nations to develop a pressurized rover, a vehicle that would allow astronauts to travel long distances without needing to remain in EVA suits the entire time. From the humble Hiten to the majestic Kaguya, from the compact Slim to ambitious international ventures, Japan has walked its own lunar path with persistence, subtlety, and quiet resolve. And it is precisely that quietness, steady, gentle, unhurried, that becomes the soft rhythm guiding the moon's story forward, glimmering like silver light drifting across a calm night lake, carrying listeners effortlessly toward the next chapters of humanity's journey across the sky. When the story of Slim gently comes to a close, listeners can still sense the lingering softness of its touchdown, settling onto a gray, dust-covered land where sunlight only brushes across the surface in narrow slivers. The near-exquisite precision Japan pursued has opened a new path, one where tiny robots may roam rugged terrain and where engineers can begin imagining the footsteps of real humans in the not-so-distant future. From the humble Hiten to the graceful Kaguya, and then to the compact yet determined Slim, Japan has woven a journey steeped in patience and meticulous care. And just as that quiet rhythm begins to fade, the moon's story invites listeners to drift further back in time, to an era when humanity's first steps into space were bold, rough-edged, and radiant in their own unmistakable way. For before the United States set foot on the moon, before Japanese and Chinese satellites redrew orbital maps, and before India's robots searched for water ice at the lunar South Pole, another superpower had quietly opened the very first chapter of the spacefaring age. It was the Soviet Union, marking a near-continuous string of firsts throughout the 1950s and 1960s, an era when every launch carried with it the hope and worry of millions. Looking back at those fragments of history, listeners can almost picture a world just emerging from war, full of dreams, yet fraught with uncertainty. In that atmosphere, the Luna missions wrote the opening pages that paved the way for every lunar endeavor to come. The story begins on January 2nd, 1959. Luna 1 lifted off with the goal of striking the moon directly. It was a time when guidance systems, trajectory calculations, and propulsion technologies were still in their infancy, yet the spirit of exploration surged stronger than ever. Luna 1 missed its target, failing to hit the moon as planned, and instead drifted into orbit around the sun. But that misdirection did nothing to dull its achievement. It became the first human-made object to escape Earth's gravity, entering interplanetary space, territory once reserved solely for natural celestial bodies for billions of years. It was a moment that opened a new future, one in which humankind realized it could reach toward other worlds. Less than a year later, on September 12, 1959, the Soviet Union launched Luna 2. This time, the trajectory was refined more carefully, and on September 15th, Luna 2 became the first artificial object to impact the moon. There were no landing pads, no shock absorbers. Luna 2 crashed into the surface at high speed, ending in a violent but historic impact. On its hull, the Soviet emblem was engraved, a symbolic declaration to the world that the era of lunar access had truly begun. For the media of that time, the image held meaning far beyond science. It was a testament to humanity's first bold leap into space. In early October 1959, timed to coincide with the second anniversary of Sputnik, the world's first artificial satellite, Luna 3 was launched. And just days later, humanity saw the moon's far side for the very first time. The photographs were blurry and noisy, but precious enough to astonish the entire world. Since antiquity, humans had seen only one lunar face. The other half had always remained hidden by tidal locking. And now, for the first time in history, that region revealed itself, pockmarked with craters, lacking the broad basalt seas found on the near side. Names like Mare Moscoviense and Mare Desideri would later be assigned based on these images, as if confirming that an ancient mystery had finally begun to unfold. The 1960s arrived with even faster progress. On April 3, 1966, Luna 10 entered lunar orbit, becoming the first artificial satellite of a celestial body other than Earth. This was not only another milestone, it was proof that the Soviet Union was inching closer to the capability of sending people farther out, beyond Earth's orbit. Luna 10 recorded data on micrometeorites, radiation, and gravitational variations, operating smoothly for 56 days. Later that same year, Luna 11 and Luna 12 continued returning sharper, close-up images, deepening scientific understanding of the moon's surface and gravitational field. By 1968, Luna 14 had been launched into orbit to support the Zond missions, test flights meant to send humans around the moon. Although the Soviet crewed lunar program ultimately did not succeed as intended, the Luna fleet built the scientific and technical foundation needed for the next era of human exploration. Looking back at these many firsts, listeners may sense the strong pioneering spirit of that time. From Luna 1 drifting off into a solar orbit, to the impact of Luna 2, to the grainy images from Luna 3, each achievement feels like an early stroke in an unfinished cosmic painting. These marks belong not only to the Soviet Union but to the entire world, for through them, humanity began to understand that the moon was no longer a distant, untouchable symbol, but a destination reachable through effort and ingenuity. And so, from Japan's subtle elegance in the 21st century, the story carries us back to the noisy, fervent decades of the 1950s and 60s. two very different rhythms, yet both merging into the same long, ongoing symphony of exploration that humanity continues to write to this day. As the Soviet Union's many firsts begin to fade into the drifting current of cosmic memory, listeners may still glimpse Luna 1 gliding past the moon before wandering into a solar orbit. Luna 2 stamping the red emblem onto the pale gray surface in a bold, unhesitating gesture, and Luna 3 sending back its striped, blurry, yet immeasurably precious images of the far side no one had ever seen before. Together, they resemble the first small brushstrokes on the vast canvas of humanity's exploration of Earth's lone natural satellite. And because of those early strokes, humankind came to understand that the moon was not an untouchable symbol, but a real world, reachable through intellect and skill. And when Luna 10, Luna 11, Luna 12, and then Luna 14 each took their place in lunar orbit, a strong scientific foundation emerged. Upon that foundation, the Soviet Union began to ponder a deeper, far more practical question. If we can orbit the moon, if we can crash into it, could there be a way to travel across its surface as naturally as we walk on Earth? That question, seemingly distant in the late 1960s, became the starting point for an entirely new chapter. While the United States focused its efforts on landing humans on the moon, the Soviet Union, after a turbulent series of crude program attempts, chose another path, quiet yet bold in its own way. Instead of sending people, they would send wheel-footed explorers, robots able to roam the dusty, cratered landscape on their own. And so Lunokhod was born, a testament to an unconventional way of thinking amid the race for the moon. The idea behind Lunokhod was not simply to place a machine on the moon. It was the ambition to build a vehicle that could truly move, that could step over obstacles, examine its surroundings, and send back images from a ground-level perspective, something humanity had only imagined through models and films. Soviet engineers designed a robot with a strange, almost whimsical shape, round and tub-like, capped with a domed lid, its body coated in a reflective alloy. Beneath that dome sat its electronics, batteries, and a radioisotope heater to keep the craft warm when lunar night plunged the terrain into metal-cracking cold. And most important of all were its 8 wheels, each powered by its own motor, allowing the robot to cross rocks, climb small rises, and avoid becoming trapped in ridges and ruts. In the autumn of 1970, years of preparation brought the Soviet Union to the decisive moment. A Proton rocket launched Luna 17 carrying Lunokhod 1. After several days of travel, the lander touched down softly in the Mare Imbrium, the Sea of Rains. On November 17, 1970, Lunokhod 1's dome opened for the very first time on the lunar surface. Faint sunlight fell onto its solar panels, antennas lifted, and from a control room on Earth, engineers began driving the rover through radio commands. In that remote place, where fine dust had lain untouched for billions of years, the wheels of the first robotic vehicle touched the ground and began turning out the earliest tracks in lunar history. Lunokhod 1 moved slowly but confidently, and it was that deliberate pace that kept it safe on a world with no air, no sound, no spectators. Only sudden slopes, debris fields, and a darkness that spread quickly as the sun dipped toward the horizon. 2 black and white television cameras served as its eyes, sending back images that let engineers guide the rover around rocks, over rises, and past small craters. A panoramic camera captured wide frames, stitching together the first near-ground views of the lunar surface. These images revealed an endless expanse, a low horizon, and a pitch-black sky where no stars could be seen, drowned out by the bright regolith. Sometimes the rover's own shadow stretched across the ground, a quiet reminder of humanity's distant presence. During 10 months of operation, Lunokhod 1 traveled 10.5 kilometers, a modest distance by Earth standards, yet a giant technical leap in space exploration. It returned more than 20,000 images, along with X-ray spectrometer data used to determine the chemical composition of the soil at multiple locations. The results showed lunar soil in the region to be rich in silicon and aluminum, similar to basalt on Earth, supporting the understanding that the Moon's dark seas are ancient volcanic plains. One of Lunokhod 1's most remarkable instruments was a French-built laser reflector. When lasers on Earth were aimed at it, the reflector returned the beam, allowing scientists to measure the Earth-Moon distance with an accuracy of just a few dozen centimeters. That experiment continues to this day, proof that Lunokhod 1 has never been entirely silent. The success strengthened the Soviet Union's resolve. In 1973, Luna 21 carried Lunokhod 2 to the Sea of Serenity. This rover was far more active. In just 4 months, it traveled 37 kilometers, a record that lasted well into the modern era. Lunokhod 2 captured countless new photographs, performed more experiments, and became one of the most striking symbols of automated exploration during the Cold War. Looking back at Lunokhod 1 and 2, listeners may picture these diligent iron crabs crawling across the barren landscape, where there is no wind, no footprints, only the tire marks of patient metal wheels leaving faint trails in the silver dust. And from that patient work, humanity gained its first ground-level view of the Moon. Not from above, not from orbit, but from the perspective of a lone explorer moving across the surface of another world. Those rolling tracks extend the story begun by the Luna missions, a new chapter, livelier and more intimate, on humankind's long, quiet journey toward the Moon. As the journey of Lunokhod slowly quiets, listeners may still picture those delicate wheel tracks left on the Moon's silvery dust, thin lines stretching across a stillness no wind will ever erase. From the panoramic maps sent back by Lunokhod 1 to the longer paths conquered by Lunokhod 2, every image allowed humanity to see the Moon for the first time from a low, intimate, ground-level perspective, closer and more vivid than anything imagined before. No longer just a glowing disk in the night sky, the Moon revealed itself as a real landscape, with scattered rubble, sudden rises in the terrain, and ancient craters that had slept in darkness for billions of years. The Soviet Union's iron crabs walked ahead of us, learning the terrain, touching the cold ground, and opening the door to an era in which robots would become humanity's first footsteps on distant worlds. But while those mechanical wheels traced their persistent marks across the dusty surface, another longing quietly grew inside Soviet engineering circles. Rolling across the Moon could provide images and impressions from the ground, but to truly understand its geology, origins, and long history, something more tangible was needed. A real piece of the Moon had to be brought back to Earth. And so, alongside Lunokhod, the Soviet Union began pursuing an equally bold and hazardous goal: to collect lunar soil with robots and return it safely home. This mission demanded extraordinary engineering, soft landing, drilling, sealing samples, and launching a return capsule back into lunar orbit and toward Earth. All of it had to happen fully automatically, in an environment where no human hand could intervene. The early attempts were unforgiving. Between 1969 and 1970, 6 spacecraft bearing the names Luna or Cosmos were launched with hopes of returning samples, but each suffered technical failure. Luna 15 even crashed into the Moon just 2 days after Apollo 11 carried the first humans to its surface. The moment was painful, a reminder that conquering the moon was not a saga of instant miracles, but a long, arduous chain of trial and error. Yet it was perseverance through failure that made lasting achievements possible. Then, on September 12, 1970, Luna 16 launched, an opportunity matured by experience. The spacecraft entered lunar orbit and then touched down gently in the Sea of Fertility. This was the first time the Soviet Union successfully landed a robot on the moon with the sole purpose of collecting samples. A small drill descended into the lunar soil, reaching down 35 centimeters. 100 grams of lunar material, dust and fragments that had rested undisturbed for billions of years, were sealed in a return capsule. Just over a week later, on September 24th, that tiny capsule parachuted into Kazakhstan, carrying a prize from a world once unimaginable. When the sample box was opened, scientists were moved. It was real soil from another world, a place no human had yet set foot. The Soviet Union did not stop with Luna 16. Luna 18 and Luna 23 failed upon landing, but each attempt offered lessons for the next. By February 1972, Luna 20 touched down safely in the mountainous region between the seas of Fertility and Crisis. This mission returned 50 grams of soil, material distinctly different from Luna 16's collection, offering scientists their first chance to compare geology between regions. Those tiny grains became keys to understanding the moon's cycles of melting, cooling, and crustal evolution. But the greatest achievement came with Luna 24, the final and most successful mission of the Robotic Sample Return Program. On August 18, 1976, Luna 24 landed in the Sea of Crisis and deployed a stronger drill that reached 2 meters deep, retrieving 170 grams of soil-spanning layers never before touched. On August 22nd, the return capsule landed safely on Earth, completing a remarkable chapter. Analysis revealed that the Luna 24 sample contained water at concentrations up to 170 parts per million, far higher than expected, suggesting that water may exist bound within deeper layers of lunar soil. This finding opened new theories about the moon's thermal history and internal structure, and it continues to be cited in modern research on water at the lunar South Pole. In total, the Luna missions returned just under 0.5 kilogram of material, far less than the 382 kilograms returned by the US Apollo missions. But the Soviet samples held a unique value: diversity. They included not only surface soil, but material from 2 meters deep, layers untouched by sunlight, where time moved more slowly, preserving traces of ancient geological processes. These missions proved that by the 1970s, the Soviet Union had achieved astonishing levels of automation. Soft landing, drilling, sample collection, sealing, ascent from the lunar surface, orbital rendezvous, and guided return to Earth, all performed in a seamless sequence with no room for error. It was a testament to extraordinary engineering and a vision ahead of its age. And when the Luna Sample Return chapter closed in 1976, it left behind a lasting legacy. Those small boxes of lunar soil, resting quietly in laboratories for decades, continued telling stories. They spoke of molten origins, cooling ages, the presence of water, and the grand processes that shaped the solar system. Through those tiny grains, humanity learned that the moon is not just a bright ornament in the night sky. It is an ancient book, each layer a page, each sample a story still unfolding. As Lunokhod left its wheel tracks on the surface and Luna returned pieces from deep within the moon, the Soviet Union created 2 parallel threads of exploration, one of mechanical footsteps and one of gifts carried back to Earth. And together, in their own distinct ways, They drew humankind closer to the secrets of that silver world, quietly circling the Earth through endless night. As the story of the tiny sample boxes returned by the Luna spacecraft gently comes to a close, listeners may still feel the quiet weight of billions of years of history resting in just a few hundred grams of lunar soil. Those seemingly unremarkable grains held within them the moon's fiery past, the traces of ancient lava, cycles of cooling and compression, deep layers that preserved signs of water, and fragments of rock that whispered of a chaotic early era when the newborn solar system was still filled with violent collisions. The 3 successful sample return missions, Luna 16, Luna 20, and Luna 24, became 3 final breaths of the golden chapter the Soviet Union had spent so long building. When Luna 24 landed in 1976 with its samples drawn from 2 meters beneath the surface, the decade-long saga reached a kind of perfect stillness, triumphant, yet also a farewell. After 1976, the moon's door closed before the Soviet Union in a slow, unexpected way. The world's circumstances shifted, national priorities changed, and resources for space exploration were no longer what they had been. The Luna program, once a proud pioneer of its era, quietly halted in the steady flow of history. The machines that had touched the soil of another world became relics, brilliant yet distant. For many long years afterward, the moon slipped out of the Soviet spotlight, and later out of Russia's as well. But that silence was not an ending, only an interlude. Beneath the dust of time, the longing to return to the moon lingered like a coal that had dimmed, but not died. As the world entered the 21st century and turned its gaze skyward once more, while the United States prepared to return to the moon with Artemis, while China and India carried out bold missions, and while Japan tested landings with meter-level precision, Russia began looking back at its own past and asking what might still be possible. If Luna 2, Luna 3, Lunokhod, and especially Luna 24 had succeeded so profoundly, could the nation step once more into the demanding realm of lunar exploration? From that question, a plan was revived: to restart the Luna program, dormant for nearly half a century. The goal was not to recreate old successes, but to extend them and meet the demands of a new era. And so, nearly 47 years after the last sample return mission, Russia announced its return with Luna 25, also known as Luna Glob. The lander was designed to touch down near the lunar South Pole, a region untouched by the Soviet Union, where permanently shadowed craters might preserve ice that survived for billions of years. The mission was both scientific and symbolic: to reach a place no one had visited, to rely on modern technology, and to reaffirm Russia's place on the map of contemporary space exploration. On August 10, 2023, a Soyuz 2.1B rocket launched Luna 25 from the Vostochny Cosmodrome. The early journey went smoothly, and on August 16th, the lander entered lunar orbit, preparing to lower its altitude. During those days, hope brightened once again. Many imagined Russia adding another shining success to the legacy of Luna 16, Luna 20, and Luna 24. But space is never easy. Lunar exploration, whether by human or robot, always hides risks that cannot be fully eliminated. On August 19th, as Luna 25 fired its engine to shift into its landing orbit, something went wrong. Data showed that the engine fired longer than intended, sending the spacecraft off balance. On August 20th, Luna 25 crashed into the lunar surface and fell silent forever. Mission control sank into a long quiet, and the dream of reviving the Luna program paused once more. The loss felt especially heavy, coming at a moment when other nations were rapidly moving forward. But failure is also part of exploration. sometimes the most important part. It reminds us that space does not yield to overconfidence, and that every advance, whether made by the United States, China, Japan, India, or Russia, is purchased with countless hard-won lessons. Russia did not attempt to hide the failure of Luna 25. Instead, Roscosmos formed a special commission to investigate. Early findings pointed to an overlong burn of the braking engine, causing a high-speed impact. No one knows exactly what unfolded in those final seconds, but what is certain is that the experience will become the groundwork for what comes next. And true to the spirit that once carried Luna 3 to the moon's far side, or rolled Lunokhod across distant soil by radio signals from Earth, modern Russia has no intention of stopping. Plans for Luna 26, a reconnaissance orbiter, remain in progress. Luna 27, aimed at landing and conducting robotic experiments, is continuing development. Russia has also expressed interest in partnering with China to build an international lunar research station where multiple nations could share data, technology, and common goals. Though the road ahead is uncertain, Russia's return is not merely about the success or failure of a single spacecraft. It is part of a long human journey where every nation contributes a piece to the greater mosaic. The moon continues its silent orbit, its soft glow shining down on Earth as it always has. In that gentle light, the ambition to explore still burns quietly, guiding us upward and onward, encouraging us to write new chapters, not just for Russia, but for the world.